All right. The recordings are a supplement material. So no, you cannot attend the Zoom classroom. And I walk around a lot. If I'm here, this captures my voice, and I would hopefully remember not to mute myself. So raise your hand if you see that I didn't mute or I didn't record. It has happened before, right? You know me. Absent-minded, I have a lot of things to do. I can add a slide for myself that hey, record, and it's just too much work. I'm using my other previous year's slide. So if the quality of the voice was not good, this is just something extra I'm doing. So if you missed the class or you had to review things and see what happened in this example, this is a good supplementary material, but you will be in the classroom because if you're my student, you know that class participation is really important. It's almost mandatory, but it doesn't say in the syllabus, but there will be a lot of class participation points that you don't want to miss. You can miss 1, 2, 3 classes. And you just miss those points, you still get 94.5% of your class participation, that's enough, right? So if you have to miss 1 or 2 classes, it's okay. I usually ask my student to communicate it with me. Don't worry that you're like 85 of you and 1 of me. Just email me if you have to miss a class. I keep record of who's missing the class. And since you always sit where you sit, I can just look and see you're not there today. So I know you're missing. Cool. All right, okay. Let's get started with me introducing myself. I'm trying to stay here so I can keep the recording going for first class. So, my name is Saïda Ziaifar. A lot of vowels in my first name and last name. If you could say my name without butchering it, I'll be delighted. If not, Dr. Z would work. So I have 2 masters, one in mechanical engineering and one in hydromechanics. I'm a very mechanical engineering person. And so the first was, I'm from Iran. So the first master was from Amir Kabir University of Iran. So it's one of the top universities. It's all of our universities are public. You have to do entrance exam and all of those. And then my undergrad was naval architecture, so shipbuilding. Then I went to China, worked for a little while in industry, in oil and gas. It was too stressful and I didn't want to stay in that industry. So I moved to US or immigrated through college. Some of you have done it. So I went to Michigan Tech, a good Michigan. I use the same joke, I'm sorry. You've heard it like 4 times. It works in Ohio State. And I got a PhD and a master on the way in mechanical engineering, but my expertise are robotics, well, control mostly, and then robotics on the way. So my PhD project was building an autonomous underwater drone for different reasons, from environmental to military applications. I came back, well, I finished that. I came to Columbus, was looking for jobs, but I actually wasn't looking for a job. I sent an email, who wants to hire me? And then they said, we want to hire you. So I spent 0 day looking for jobs, just sent an email. But I did a lot of building connections. So that's how I actually emailed the right person. Started here as a lecturer, got promoted to senior lecturer last year. And then this year I applied for a new job. So now I'm assistant professor of practice, meaning you all either went through me, like through 2019, you have capstone with me, you will have capstone with me. So if you're in capstone 1 right now, you will be in capstone 2 with me anyway, next semester. So I will see you again. If you're from ME department, this is the last time you see me, hopefully. So I just have to be with me this semester. My goal always is to make the class fun for everyone, right? Including me. So I consider both of us our time and schedule. For example, I try not to stay after the class too long because I'll get stuck in traffic when I go home, but I will have office hours. So if you have quick question, you can ask, you can walk with me to the ECE department and then, or attend office hours or email me. Can we meet up on Zoom? Yes, we can. You don't have to come to my physical office, but if you wanted, you can. I won't give any credit for you to come into office hours. This is just extra. So I'm not those kind of professor. If you came to office hours, you get extra point. If you came to the class, you get extra, extra point participation, right? So you get those. So just be here, you get a few points. Area of interest on top of robotic control is also capstone. So real life projects with sponsors and then how engineering works and all of that. Any question on those things? Like very introductory. Now, if you haven't had classes with me, I will go through my Carmen page and show you how things are organized. I communicate with you mostly through Carmen. Announcement, discussion board, my modules I try to keep them organized. I always ask what else can I do to make it better. I really like to have a Discord classroom. I usually have in my classes, but requires that I have a grader. I don't have a grader. So once I have a grader, we can set up our Discord and basically lets you ask your questions while I'm teaching, but not raise your hand because you don't want to interrupt me or you don't want to ask, but your grader or other student can answer you. That has to wait until I know who is going to be my grader. All right. If I couldn't find someone, then I will just have you guys to manage the Discord and I'll check on my phone what's going on. Right. Okay. So when we hear robots, there are two things that we need to be mindful of. What is a robot? If this is a robot or this is automation, right? So how can we separate these two? Like, what's the indication that something is a robot or something is an automation? Anybody? Usually, if you look at the slides, the answer is there. So I don't want to read from my slides. But just hearing robot versus automation, what do you think? Yes. So repetitive tasks that are over and over and over. What else? And think of robot. What would be a robot? You're in robotic class. I expect you to have an idea. Yes.
A system that kind of has to make choices depending on the environment and sense the environment around it.
Yes. So basically, that's what's the big difference between robots and automation is that the robot will make decisions. So think about your washing machine. What's the process of washing your clothes? Who has washing machine at their dorm house? Okay. Can you tell me the process? What do you do when you want to do laundry? Except giving to my mom. We dump it in the machine, press the button, and come back tomorrow, right? They stink, put in a dryer, and then wash again because they stink. Who has done it? Me, because we forget, right? So it would have been nice if the ding, 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 ding was like on our phone, like yelling at us, hey, your laundry is done, right? Someone can do that. Very simple. So is that an automation or a robot? Automation. So a machine is smart, right? A machine is smart, it's pre-programmed, it has some tasks predefined. You put the load in, close. There are sensors in there because it can tell you if it is dry or not, depending on how expensive or how much money you paid for it. And then you press a button and it tells you things are ready in an hour and 20. Do you know how they calculates the number? Like, so I got from 59 minutes to an hour and 20. So how there's a weight sensor, weights the clothes and say, okay, this many kilograms, I don't think it's in pounds. If this is kg, this many kg, it's gonna take this much. Or if it is bedding or, like a sports, so all the pre-programs. Then decides, I'm gonna wash it for an hour. If it's clean or not is not my problem, right? It's automation. So there is a predefined program task that you will put your clothes and then you open, and then same thing for the dryer. Hopefully the dryer is smarter, but sometimes it doesn't dry the clothing enough because it might not have a sensor that if it is dry. It's a task. So you repeat the task again, put it back there and turn it on. Usually with bed sheet and the clothes, it happens. So you have to do it again, right? So those are automation. Now, when we have a robot, there are sensors, and the decision that the robot makes is that, well, there are automation inside the robot as well. the decision that that machine makes is based on the sensor readings and some pre-program from a human that if this case happened, do this. If this case happened, do this based on the measurement. So that becomes a robot. Now we also have different kind of robots. Can you name some robots that? A Roomba, it's a robot, yeah. What else? Dark. Yes.
Like six-axis controller.
Yeah, robotics arms. So this class, you need to participate, meaning that you need to talk. So those of you that were in my class, you know, I literally pointed you. And you have to like send me an email. Can you not call me in the classroom? Because I do that. It's fair. So the survey I'm sending you, like the pre-class survey, if you're a person that has anxiety, doesn't like to be pointed in like in the class, you need to tell me. And I need to know who you are. And try not to do that. Like, Michael, what do you think? And he's like, I don't know what happened in the last 20 minutes in the classroom. So, and it's okay if you say, I don't know. Sometimes you don't know. Sometimes the question is for you to actually think. I'm not looking for an answer. I want you to think about the topic that I'm talking about, all right? So if you're uncomfortable with answering question or being called out, you need to let me know. And I'll try my best to remember and not do that. I usually do, all right? But as engineers, you should be able to think on at the same spot. The answer could be wrong, which is okay. All right, so the robot sense, plan, and act. So it does the task as well, right? Now, sometimes we have a more complicated system, the robot system, right? This class, this is the part that you want to listen if you belong to this class or not. This class will discuss manipulators. So there are links, there are joints. This one is not as smart, doesn't move on its own, right? It has everything, but it doesn't have the, what doesn't exist here? The actuation, right? So it doesn't move on its own, but it's just a structure that is capable of moving. So all the manipulators look like that. They have joints, links, they can rotate, or they have a prismatic joints which goes right and left or up and down. Also, you want to be on time. That's one of the cases that put you in the spot, right? So now, when we are studying robot system, there are different topics that comes in, and a lot of it at the beginning is theory. All right. So if you're an ECE engineer, ECE student, that you're here because robots use PCBs and sensors and motors, and you're excited for that, you don't have them here, right? But nobody goes and say, you know what, I want to build a robot that helps blinds to walk or move, or, you know, they don't say, okay, let me buy this motor and this sling and build things. Nobody does that. Everybody starts from, let's simulate things. Let's think about what kind of components I need. What's the design? And once they are good and they're sure the simulation works, they then start building it, right? So we're doing that first part. So we are gonna do a lot of kinematics. I will tell you what kinematics means. If you don't know, it's different from kinetics. Kinematics, dynamics, then there's actuation, right? So if you're a mechanical engineer, you know the inside and mechanic of actuation. If you're electrical, you use them, right? So you might not know what's happening inside, but you know how to use them. Sensing and perception, all the sensors and how we get data and how we use them. Then there's planning and control. So if this robot wants to go straight and turn right, that's planning. And then you want to turn right with this rate, that's control, right? Don't hit the wall, that's obstacle avoidance. Then the mechanics, the manufacturing, building part, which we don't do. And artificial intelligence, which is the brain, the programming part of the task, right? So robots might all of them need path planning, but every robot does a different task. So that part is the artificial intelligence that tells you how to do that task. We also don't do that very heavily here. So what do we do here? Why am I here? we are gonna go over theories of kinematics and dynamics. All right, so math, including algebra, like vector, also algebra, a lot of matrix multiplication, differential equations in dynamics, it's just differential equation. Simple math. So a lot of things that when you were in GE in the first years, like you're taking a lot of courses and like, why am I taking this? I'm not going to use them. This is the course that you're going to use them every single time we meet. So at the beginning, I usually ask you to go and review those material. So refresh yourself, and then I'll give you the topics. What is it that you're going to use this like this week? So you make sure that you remember or know what lecture from past to look, or use your friend Google. All right. Once we're done with dynamic, then we will work on motion control. So if you had any control course, ECE is 3551, ME is, or MAE, what's your control number? Course? 3260. So it's introduction to feedback control, basically. I'll touch base on that, and there are a few control methods that we're gonna go over. We don't cover all of them. We use PID controller and some force control, basically. The basics that enough to get you started with robotic. We touch base on actuation a little bit, then trajectory and motion planning. That would be the end of this course. So everything here, so in the green box is yes, we are doing it. Well, here, we are not doing it because there is another course in MAE department, 7,000 something. So they go through to this part. So it's more advanced. You need to have all the basics to get there. So if you're graduating, this is a nice entry to robotics, and you can study if you are interested in the next phase of your career. If not, I think it's enough that if you go talk to someone, if you want to work for a robotic company, you have enough to talk to them. I'll give you enough fancy words, let's say, technical words that you're able to go through an interview. All right. And who knows what's the name of that robot? Chappie. If you haven't watched, go watch it. It's very, very good. It says Chappie, right? Chappie and Daddy. All right. So main topics of, I'm gonna walk a little bit toward the word because I really hate being here. I try to be loud. Do you guys hear? Do you back of the pack? So all of these are posted on Carmen. You don't have to take pictures. You don't have to worry about. I'll show you where they are. I'll post my annotated version. So whatever I say, I think is important. All right. So Michael, what is your advice for everyone when they come to class?
Download all the slides.
Download all the slides before you come to class, so you can take your notes as we go. You see my first few annotated lecture, and you see what I put in there. So you kind of get an idea of what I don't put in there. Those are the notes that you will add, right? So there's a learning curve, but you don't have to take a picture and be worried. You also need to stay awake. So kinematics, who knows what's kinematic? You can also read and tell me. Motion, no. That's exactly what it's not. Good start, yes.
Understanding condition.
Good start, yes. So, anybody wants to check some slide? Maybe read the slide? Yes, okay. So assume I'm a robot. I don't know. So let's just look at the arm. There is a link here. There's a joint here. There's another joint here, right? There's another joint here. And there's shoulder. So everyone has that, right? We can check. So having the link, what kind of joint this is, possible ways it can move, but we don't care about the motion. But it can move in 3D, this one, right? Like ball bearing. This one, elbow, only has one and is limited. I can't bend it backward if I could go here. So I'm limited by this, right? But some robots they have. So this one 80 as part of this configuration, right? Orientation and fit and position. Also the risk. So this is kinematic. How to change the links are connected and what are the tools. You're gonna study this. So any system you want to design, you need to first design this. The linkage without moving, without motion. But you need to know what's the test space. So where does this have to be? Then you know how long is the limit, right? If I was not able to move, I only can reach up. So like if I wanna grab the pen, I can't. It's outside of my capacity. But since I'm moving, like the mobile robots, I can do it. Right. So, dynamics talks about the motion. So all the equations with F equal ma, F equal mv. So velocity, acceleration, mass. You bring the mass now. You bring the forces. That's dynamic. Mechanical engineering, you probably had dynamic community class, so it'll be a lot of repeated, but it will be connected to our topic. So there will be some overlaps. All right, and I want you to just be patient and go through fast. Don't write in my CI these classes on board. Not everybody has it right now. Right? Because I'm a mechanical engineer, I understand. You have to go through it again. Okay? Finding how to define the path of motion of the body to go to the direction you want, right? We're gonna have and control what's the desired motion. So think about your car. Cruise control. It's very nice. The car cruise control is end of the day. It has a early day. So your cruise control is a control system, right? You want to go 55, you set, and then you take your feet off because your feet is the control how much gas you're putting in the throttle, right? Now you're taking it off. It's automatic now. So that's the control part. But how to design that? There's a system behind it, intelligence that makes sure the angle, the pedal stays. And then you go on the you climb, and then the speed drops a little bit, and it catches up. And if you are driving old type of pretty jerky motion to get back, right? So those are control. We will discuss those things. So anything outside of this, we will not touch. Now, if these are the things you already know, I think you should drop because it will be all repeated. I want everyone to be in the class. Don't get me wrong. But my past experience says, when you're here, this is an elective course, you want to learn something extra of what you knew, right? And I don't want us to waste your time and money learning things that you already knew. So this is a very introductory class. It's 5,000 because it's open to both, but introduction, like lower level for graduate students, right? Oh. All right, any questions so far? We will get back to robotics, don't worry, but I need to explain how the course works. Because I know you're all worried about your grades. So, class participation and quizzes 15%. These happen in the class. The questions are usually simple, sometimes maybe not, maybe a little bit like thinking, but usually very quick, short question that is about the topic I just taught. I wanted to make sure you learn. Or if you didn't, you know you didn't. Sometimes it's based on completion, sometimes it's based on correctness, I will tell you. Now, if someone is just at SLBS, this quizzes won't get extended. These only happen in the class and gets closed in class. With some exception, which I will tell you which one they are, the credits, because they're a little longer. But you have to be in the class to get these 15%. Right? So if you want an A, you want to be in the class. If you're someone that you might be in trouble, you also want to be in the class. If you're halfway in between, that's fine. If you want to be in class, you can sit back. Written assignment, we show your homework 20%. Most of them are close to what I teach. Some of them are a little bit difficult because you need to think how to connect different topics, right? Programming assignments. There will be in MATLAB. So if you don't remember MATLAB, or if you never had it, or it's been a while, you want to go read MATLAB 101. I really think I put the link to MATLAB tutorial in my module, so you can go ahead and use it. I will start from a very simple programming assignment with individuals, so everybody they have to use MATLAB commands. I think I did the same thing in my physical class. I kind of get you on board, and then it gets more complicated as you go. When you get to a point that you're actually solving problems, then you will be dividing groups. So programming assignment will be grouped. If you're a graduate student, groups of 2. If you're undergrad, groups of 3, I think of 4. Because assignments are usually bigger. Now, when I say group work, some of you are like, yes, great. Some of you are like, oh no, I'm the one that does everything, right? You need to communicate it with me. If someone is not doing their part, carrying their load, they will be out from the group, they work on their own. Becomes individual, but I expect the same quality of work. So if you don't contribute, you have to do it all by yourself. Right? So I will let you decide, yes.
How many of these science?
Oh, I don't remember, maybe 4 or 5. So these 2 exams are like written exams, you have to come to class. This one, so usually final project, but if we go to, I don't know, COVID hits again or something, it might be final exam, right? So this one is a really big project. You can't do, like, I mean, you can do it by yourself, but I wouldn't know if you're a person that can actually do this big project. It's a big simulation of a robot that does some task, follow task. So it's an accumulation of everything you learn, right? So the goal is to build up to this, so all the assignments are actually connected and building up to end here. So I'm not giving you a new project at the end of go solve it. It's the continuation of everything you have done. And then that's 100%. Any questions so far on those? All right. At the beginning, I think it's better if you do all the calculation by hand, especially because you have vectors and matrices and you hate doing all those. But I want you to do it. You become comfortable again with that, then I let you use calculator. So for example, for your first exam, I might not let you use the calculator. You should be able to do vector multiplication or matrix like 2 by 2, 3 by 3, or determinant, all those, right? So get comfortable with that. Some of the CPs require passcode, and I will stop the Zoom recording, tell you the password, then start it. So if you're not in class, you don't know. Now, if you're in class, your friend is not in class, and you give them the password, I would know. Trust me, I've done it. And that's not beautiful because I'm trusting in you, giving 15% of your final grade, which could have been one of your exams. So instead of 20%, 15% could have been 30%, right? So I'm kind of giving you a free pass on 50% of your grade. If you betray me, I'll punish you personally, not as a person. I mean, I punish you personally, not personally. Personally, I'll punish you personally. I'm sorry. So don't betray my trust, and don't bring it for everybody else. All right. So my grader, one of the job of the grader will be to find out who is that person. And just because I want the system to work, but if we find too many leakage, I will take the whole system out, and 15% will go to your one of the exam, and you like, oh, if I fail this exam, I failed the course. Right? Make sense? All right. No late submission is accepted. 0 tolerance policy. If you had a course with me, you know, I do not accept. Life happens though, you know. Then you have to communicate with me, but it's very rare occasion. I usually give enough time that you have time to plan. Do not do anything in the last minute, because I assume everybody does everywhere else. Carmen, of course, is not going to work. You can't submit. That's not my problem. You waited until last minute to submit, so it's on your part. But if something happened in the family, you got sick, something that you even planned, it took you 2 to 3 days, that was the weekend you wanted to do, you'll come and discuss with me. Right? Or if you know, you will discuss in advance. All right. So I'm really big on this, and I've given 0 to my students and cost them 1 letter grade. So. Yeah, I talked about the teams, 3 to 4 for undergrads, 2 for graduate. If you're friends, you want to be in a team, I don't mind. So I'll create on Carmen and then you can sign yourself up. I'll do that next week because we don't need it right now. Ask questions. Don't worry about it. There is no stupid questions. There's no wrong question. You just don't know it. Even I might have talked about it. You will not pay attention. You can ask. The thing is, if you don't ask questions and carry, then you might not understand anything after, right? When we have a Discord thing, you can just type in the Discord and someone else can answer you. Meaning, if you check your phone during my class and I'm talking, I won't say why you're checking your phone. I assume you're adult, you can decide for yourself, do I need to check my phone right now or not? Right? So it's up to you. The recording are not like super good because you see how many times I walked away and this is not going to pick up. So paying attention in class is probably your best chance. Or come and see me and discuss, not after class, not office hours. Course material, the book, you don't have to buy it because it's online. There are a bunch of YouTube videos. Basically, the author recorded videos and talked about all the chapters. I don't follow chapters and all materials as book does. So I use this book a lot also. So if you had a SPOM, I think that's a better reference, but to keep it similar between the two departments, we chose that book. All right. A lot of what I teach is you can find it there. There are a couple of differences that I will tell you. This one you cannot find in this book. All right. So I'm adding more to what you would learn if you just read that book. Again, everything else we provided. So take use of Carmen. Now we're gonna go to Carmen and check out how the course works. I'll try to keep it short because I want to discuss Carmen. I mean the course with you. So everybody, when you go to Carmen, you have to see this. Module is where I communicate with you. I'm gonna put a student view, so only see what you actually have. Is that a student view already? Not. Yes. So getting started, and review is very generic. Student resources, these are all the stuff I put. And you can, if you're not familiar with something, go here and read about it. So modules are weekly. So week 1 this week, I put my lecture notes. So here today, introduction to robotic 824, right today. So you'll see that I have my blank slides. Once the class is over, I put the link to my annotated slides. Then I put the video of recording. This might take a while because I have to go home, YouTube, and all of those. And I don't think anybody would want to immediately see me again. So this is just more for the review. This would be your best friend. So I usually publish this on Sunday. I try. So you know already before coming to class on Monday what's going on. Sometimes if I don't have the slides, I might just upload before class, but I try to be good. And assignments, you will see all the assignments here. They are dated, meaning that you get them on your calendar. You get them as soon as you open the course. You get there where you get a notification for your assignments. There are supplements, which is all the things that you should know. If you don't know, go read them. If you already know, you don't have to review. All right, so optional. There's a fishbowl. These are anonymous surveys that has 2 goals. One, if I talk about a topic you didn't understand, I didn't talk enough, or you want me to discuss more, or solve another example, practice example, write it there. It's anonymous. I don't know who it is. That's not important. You just need to tell me what you need to hear. Second, I might have said something stupid, and you want to know why they say that. Like I hurt someone's feeling or said something insensitive or unprofessional. It happens because first, my culture is different from yours, even though I lived here for 10 years. Second, I am a human like you, might have had a long day and say something and didn't think about it, right? And it's insensitive. So you can tell me, and if I see that I can discuss in the past, I will do that. And I have apologized for some of my behavior. Just I say stupid things. It's on record. Okay, so basically creating an environment that you can give me feedback without me knowing, but I want you to be polite about it. So you see that some weeks, I don't put it there because I know this is a crazy week for me and I can't take feedback, right? So I just don't give it to you. You just have to come talk to me. If it's important enough that you can come talk to me, then you can. I try to be open and accept different views, but again, factor that I'm a human and I'm a mistakes, okay? All right. Other things that you see here are the discussion board. You can see all the assignments that are published here, all the quizzes that are published here. You can see your grades and then record your name if it's not, so I know how to pronounce them. You don't see file. I don't put all my files there. I have a very organized system. I assume that you will have a folder that dump everything in there if you need it. Or as we go further, there will be a module, like a link in the module that says lectures. I put all of my lectures there, so you don't have to go which week we talked about this. I'll put all the assignment and solution also in a separate module when we have them. All right. So if you think that there should be something that make it more accessible for you, feel free to tell me. All right. Any question on how Carmen works, how this course works? This is really important. This seems trivial, but this is basically where you get your information from. If you are emailing me, please only send to @osg.edu. I don't have Buckeye mail @osg.edu. I won't see them, especially if it's a special, like something time sensitive. So don't write zifad.1 and hit enter. It was sent to Buckeye if you haven't emailed me before. All right. And this is my Zoom ID and passcode. So if you're meeting me in my virtual office, you already have them. So don't ask me, where do I see you? Just ask what time we meet. Okay. I'll let you breathe for a minute. So I bring my Zoom back. Robotics stuff now. I'll still give you your minute. Don't worry about it. Oh, right?
Yeah.
I will remember your names and your face. It doesn't mean anything. I like to know your name. All right, so if you have the slides, you can hold them up, follow me. If you just want to sit back and relax and listen, you can do that as well. Don't talk to each other when I talk. That's my rule. When I talk, you don't talk. It really bothers me because like I have ADHD and I would want to be in your conversation, but I'm also talking. So I have to know. All right, so before starting, so next class is actually like Monday when we actually start the course, but I thought I should give you some symbolic representation, like how do we address the joints and the links and everything, right? So a robot manipulator is composed of links and joints, right? The links, we don't care about them right now as long as they're there. Because material, length, weight, for kinematics, we don't care about mass or anything else, right? They just need to be there. Then there are joints. So joints connect links together. So link 1, link 2, this is joint 1, connecting link 1. This is a kinematic chain. Now we have two kind of typical joints. One is revolute joint, which rotates, right? With different limitation, but always rotates. We show it by R, like the hinge of the door. When you open the door, that's rotation motion, right? So we call them R. Then we have prismatic joint that is slides. Have you seen the slider? Those are our prismatic, we show them with P. Now, in 2D dimension, so you should be able to draw them, right? Like when we are analyzing our system. So revolute joints are basically, you put two links, it could be two lines and a joint. And you need to tell me this is R and then which direction this is rotating. So these are the minimum things you need to demonstrate when you are showing the joint. Joint has to connect two links. So you can't have, what does it do? What is it rotating from one side to the link, right? So it's always a link, joint, a link. Prismatic in 2D would be, you can show them with this, like a dash pot or damper, right? That's basically what it does. And also show a direction. So some of the prismatic joint, they actually slide, go both direction, back and forth. Sometimes it's just only one way. Who mountain bikes or has a motorcycle here? So the suspension, right? So you go down and up. So you pump, we call it pumping it, right? So it's a prismatic joint. It could be one direction or actually go and back two direction. So you want to show the direction. So two-way arrow means that it goes both ways. If we want to show them in 3D, so we show them like a cylinder for now. That means if you see a cylinder, it means that it's just one joint. Cylinder, because then we can show which way it rotates. So this little thing is rotation, meaning that one link is rotating good, right? And they're all rotating around this axis. So we'll get to that more. For a prismatic joint in 3D, so it's a cube usually, and this plate that's extra drawn next to it also shows which direction it's going. So this one can go to both directions, so probably the 0 is here and this whole thing can move. These are representation when we are drawing. This is not the actual joint. Make sense? So always show the direction. I've written it in my annotated slides, so you can remember that. Now, this is a robot. This is ABB. This is real life. This is what we put on the paper. Now, how do I tell you? So I saw this. You're in the team. I went to the factory. I saw this, and we want to analyze. I need to draw something that you understand what it was, and you haven't seen the picture, right? So we find all the joints and all the links, and we present them. Now, these robots, so this one doesn't move, right? So we don't deal with mobile robots. Everything is fixed. So there's always a base, which is here. We kind of show it with ground, and base doesn't move, and is always your link 0. So this is going to be 0, link 0, and then we start. So your base is a link. I said link 0. So you need a joint and another link now. So this is your first joint. This robot, have you seen one of these working in video? So this is basically shoulder, elbow, wrist. So it's like resembles. These are called articulated robots because they resemble human body. So we have a joint here. So this is the body or the base thing that doesn't move. There's a joint here. There's a link here. There's another joint, link, another joint, then the rest connects to other things. But you're going to just look at those first 3. So you have a base. There's a joint. That's not a good color. There's a joint. There is a joint. There's a joint. I need to find all the links connected to it. So you start drawing them. The base joint that rotates. So I use a rotary symbol, right? The cylinder, and I show the way that the rotation, the direction it rotates. Our joints always rotate along z-axis or move along z-axis. We will learn why, but for now, accept that. So this is rotating around. So if the thumb was the direction of this axis, the rotation is your forefinger closing. Always use your right arm. Everybody, right arm up, direction, and rotate, right? So you just move backward. Now, tell me if that Z1 is correct. If I need to rotate that way, does Z have to be that direction? Yes, it is. So I'm gonna change something that, like, from this slide onward, it is corrected in my annotated version. So I'm gonna call this Z1. Well, this is gonna be Z1, Z2, Z3. I'll tell you why later. But we're gonna start with one. So Z1, Z2, and then is Z3 correct? So if Z3 that way, we will rotate in this direction, right? I want you to get comfortable using the axes and the forefinger that shows the direction of rotation. All right. So now, what kind of joint do you see in this robot? In this robot? Yes. Revolute. How many? 3. So instead of saying 3R, we say RRR. The reason is that when I say RRR, I'm telling you the configuration of this. Means that there's revolution, revolution, revolution. Now think of if there's a robot that has 2 revolutes, 1 prismatic. If I don't tell you what's the configuration, there are many ways that you can build that robot, right? ERR, RPR, RRP, right? So to be clear, to tell you the configuration, I put them next to each other. So here is RRR, it doesn't really matter, right? But we just follow this. So when I wrote RRR there, that's what I meant. There are 3 rotational joints. Now we show them by Q. We call them joint variable. Theta 1, theta 2, theta 3. Why did I choose theta to show rotation? Well, probably because theta represents angle and it's arbitrary, but if I tell you theta, you know that I'm probably talking about rotation, right? Think of opening the door 30 degrees. So if I call that theta 1 equals 30, right? So this is called joint variable because you don't know what it is. You only know that it moves in this direction. That's what kinematics means. You don't care how many degrees it's rotating. It's just rotating. Right? It's a big difference. So right now we don't care what the values are precisely, we just care about the variables. So Q, my joint variable are 3 things. Theta 1, theta 2, and theta 3 for this articulated robot. So what type of robot is this? RRR. How to describe the configuration? Q is, well, basically this. So this is called joint variable. Yes.
Does anybody ever abbreviate it 3R? Like if say RRR.
Yes, so those are called chain robots. So if they're all the same, we also have a rule that since they are 3, then you know how many units they also have, right? So only when they're all R, yes, you're going to say like NR. N number of points. But I did that because then this is not RRR, and then it was harder to come from 3R now to RRP, right? So can you see from this? So this one, this is R, it's prismatic, this also moves forward, it's prismatic, right? So no, R, sorry, this rotates, and this one's prismatic. So you have R, R, P. So if I ask you to write what's Q, what do you write? Q was your joint variables, right? I already named the joints. What is Q? What's inside Q?
Theta 1, theta 2.
Yes. So so D usually represent distance, right? Prismatic, it's a distance in X, Y, Z direction, and you will know that it's always Z direction. We call that direction Z always. So this is going to be theta 1, theta 2, D3. This is a very important piece of kinematics because if you wanted to actually start even working on this, you need to know how they are connected to each other. The order, which is the configuration. Now, remember this was RRP, so 2 revolute, 1 prismatic, right? This is also RRP, but it's very different. So if you look at here, the direction of this Z-axis is in this direction. This Z-axis in this, so these two coincide, right? But this one is RRP. This is your Z1, this is your Z2, this is Z3. Now these two are parallel. This changes a lot when we are modeling this. These two robots, they look very different when you're coding and when you order them to move, because that's what you can do. The kinematic, you can tell the computer how they are configured and connected. Then dynamic is you're gonna apply force, actuate, and they're gonna start moving, right? So those are RRP, but very different configuration. So Q here is still theta 1, theta 2, theta 3. The difference is the direction of your Z-axis. D3, yes, D3. Now you'll see that sometimes we call that theta also because it's just a variable, but for now we keep it D and theta. So for you, you know, try and look at which one is prismatic. How about this one? Oh, too fast. Don't look at that. What's the configuration here? What's this type of robot? When I say type of robot, you look at the joints and call the joints. So RPP, right? Now, what are your joint variables? So RPP, Q, joint variables Q, theta 1, D2, D3. Now I'm going to correct I'm going to call Z1, Z2, Z3. The reason is we want them to match the subscript. There are two different ways of naming them. There's a traditional way, a new way, we're doing a new way, because all of the rest of the lecture will be new. So if you ever wanted to go and consult with Google on your assignments, you do the extra mile, and usually most of the solutions out there are the traditional way. Everything I do is the new way, but you have to do it. It messes up. So if you're consulting, just make sure you do it properly. How about this one? PPP, very prismatic, right? Like you've seen like printers, right? They just need to go along an axis. So these basically are different machinery that you need them to do things in the workspace, and they translate into basically how the joints are configured. And then we model, then we actuate, and it tells us how this thing moves. We're gonna learn that in this class. The first part in kinematic, you're gonna learn that. So P, this is Z1, Z2, Z3, Q is, sorry, D1, D2, D3. So my 1 and my comma look the same. So D1, right? I think it's the last slide. Yes. So I'll post the actual clean annotated version. Things you need to do. They're not due yet, but don't forget that you always see this thing. I'll remind you when it was. Sounds good?